Welcome back. Today we're going to talk about functions. I'm going to introduce functions and talk about, as we've seen before, the dependent and the independent variables. We're going to define relation, we're going to define function, and we're going to test to find functions and see the relationship that functions have. Just as a review, we're going to work with dependent versus independent variables, and you may recall that our y depends on x. Okay, so our x is going to be our independent variable, and our y is our dependent variable. So any ordered pair, x and y, can also be seen as the independent variable and the dependent variable. And we're also going to see how x and y can be seen as inputs and outputs. Okay, we'll input a value or an x into a function and generate some sort of output or a y. So a relation, as definition, is simply any set of ordered pairs. So any x and y is a relation. Now a function is a special kind of a relation. A function is a relation for which every input acts that there is exactly one output. Okay, so something like the ordered pair -2, 1 and 1, 1, that is a function. We can input -2, we output 1. We can input 1, we output 1. Okay, so we have an output, a unique output for every input. Whereas if we had -2, 1 and -2, 3, now that's not a function. We have the same input, the same x for each of these, but we have different outputs. Okay, so that's not going to be a function because if we input -2, we don't know what we're going to output. We don't know if we're going to output 1 or 3. So that's an example of something that's not a function. I think that's a little bit easier to see visually, okay, as opposed to ordered pairs. So here's another example of something that might be a function versus not a function. So let's look at our mapping diagram here. We've got two maps. In one group we have 3, 4, and 5. Those might be our inputs, our x's, and 2, -3, 8. Those would be our outputs. So an example of a function, so if we input 3, we output 2, we input 4, we output 8, we input 5, we output -3. That would be an example of a function. For every input, we get a different output. Okay? So the red, those are functions. And this too would be a function. If we input 3 and output -3, and if we input 4 and we output -3, well, those are both functions. Okay? We have different inputs. Even though we have the same output, we know exactly what we're going to get. Here's an example of something that wouldn't be a function. So I'm going to erase these. And put my group back up here. So I have my two groups again. But here's an example of something that is not a function. If I input 4 and output 2, and if I input 4 and I would output -3. That's an example of something that's not a function. Okay? Because I've got different outputs for the exact same input. I can input 4, I don't know if I'm going to get a 2 out or a -3 out. That's not good. There's some ambiguity there. That is not a function. And we can also see on the coordinate plane examples of functions, things that are functions and things that are not functions. And we have something called the vertical line test that can prove that for us. Okay? So if I just draw a line, Okay? A single line here, this might be the equation of some particular line. We can check by drawing a vertical line. And if our vertical line crosses our function only one time, it's a function. Okay? It passes the vertical line test. So a line, or even a parabola, something like this, those are functions. Okay? I could even do a kind of a squiggly line. I could do something like this. Okay? So that also is a function. No matter where I draw a vertical line, it only crosses the graph of that one time. Those are all functions because they pass the vertical line test. Now, if I drew like a sideways parabola, something that looked like this, this would fail the vertical line test. For one value of x, this x is 2, I could have a value of y down here, it looks like around -2, and a y up here of around +3. This fails the vertical line test because it hits my graph twice. Another way we talk about x's and y's, or inputs and outputs in functions, is the domain and the range. The domain is the x values, or the valid inputs. That's our independent variable, of course. And our range is our y value, or our outputs, or our dependent value. So we have inputs and outputs, we have x and y, we have dependent and independent. Well, we can also have domain and range. So once again, an ordered pair can be x, y, inputs, outputs. It also can be domain and range. But generally for domain and range, we look at what is the domain. We say what are our valid inputs, or what are our possible outputs. So listed here are a couple of different kinds of graphs, okay, on the Cartesian plane. And we want to look at this and ask ourselves, what are the valid inputs? What are the valid x's here? Well, on this particular line, I can input any fraction for x, and I'm going to get an output on the line. So if I input, 1, it looks like here I output 0, a y. So that looks like the ordered pair 1, 0. So I've got all sorts of ordered pairs on the line. And is there any x that I can't put in? Can I put in -100? Sure, it's going to be way up here, but we'll find an output on the graph. Can I put in, 1,000,000 for x? Sure, it's going to be way, way out to the right, but we'll find a corresponding output on the graph. So as it turns out, our domain for this particular function is all real numbers, and our range for a line as well is all real numbers. Let's take a look at this red graph here in the middle. This is a parabola that opens upward. Okay, it is a function because it passes the vertical line test. Well, what are my valid inputs here? What's my domain? Okay, well, can I put in 0 for x and get a y? Sure. Can I put in 1 or 2 or 3 or 4? Yeah, I can. I'll get a y, or an output that might be way up here, because this keeps going and keeps getting wider and wider and wider. So my domain for the red, I can put anything I want in for x, all real numbers. Now, my range is a little different. My range is my valid y's. Okay? So what are my valid y's, or my valid outputs? Well, if we look carefully at our graph, we have no outputs that are below -2. Well, we got lots of y's that are above -2, but none that are below. So our range here, our y values, are all real numbers greater than -2. Okay? And it's not real clear here, but let's just say all real numbers greater than -2. Okay? It looks like we're not including -2 here. Now the green one, that's a little different. Now the green one, that's not a function, it's a relation, but our domain here Let's take a look. I've got x's here. I can input an x. Now I'm going to get two y's out, but it still is, we still have, outputs here that are to the left if we input a value, a positive value for x. Now, can I put in -1 or -2 or even -1/2 for this green sideways opening parabola? I can't, because I'll never hit my graph here. So my domain, my valid inputs for this particular green sideways opening parabola is all the real numbers that are greater than 0. So my domain, my x's, have to be greater than or equal to 0. Those are the valid inputs. Now the range, on the other hand, that's going to be all real numbers. This thing keeps going and getting bigger and bigger and bigger and keeps getting smaller and smaller and smaller. So my range is all real numbers. I can have any output I want here. This step graph, now this one's a little tricky. Let's take a look at our step graph. What is our domain, our valid inputs? This looks like that's -4, -3, -2, -1, 0, 1, 2, 3, 4. And my y's, +1, -1, -2. Let's take a look at our range, first of all. Our range. What are our y values? Well, it looks like I only have a y of -2, a y of -1, a y of 0, and a y of 1. I can't get anything that's in between here. Okay, these were all continuous and flowed straight through. Well, this one, we've got empty space here. So we can't have a half, or -1/2, or -1.5, or -5, or 3/4. None of those are valid y's. So our range on this one is only the valid y's, which are just -2, -1, 0, and +1. Our domain, on the other hand, a little different. Our valid x's, well, we don't have any x's that are less than -4. In fact, we have an open dot at -4, so we aren't going to include -4. But these are all valid x's here. We can input -3, we can input -3.5, we can input -2.5. We can even input -2. If we input -2, we'll output -2. Okay? And we can input any fraction between -2 and 0 as well. In fact, we can input any fraction between 0 and 2. We can input 2, we'll output 0. But if we input 2.001, our output's going to jump up to 1. So it looks like our inputs stop here at 4, and they stop here at -4. So our domain, our x's are greater than -4, not equal to, because we have an open dot, and they're less than or equal to, now because I have a closed dot here at +4, at +4. So for this particular step graph, my valid domain, my valid x's, are everywhere between -4 and 4, but we include 4, because I have a closed dot there. Here I don't include -4, because I've got an open dot. So that's the first section on functions. We've talked about domain and range, and determining what our domain of a function is, what the range is based on its graph. We've talked about the vertical line test and a mapping of what's a function and what's not a function. And we've defined a relation versus a function. So stay tuned for function notation in part 2. In the meantime, we'll see you in class.